Hello everyone. Today I am talking about the research paper titled Writer Identification from Multilingual Handwritten Indic Text Document Images. Today's agenda for the discussion is as follows. So writer identification is the process of identifying the writer of an unknown handwritten text, and it involves capturing features in the handwritten text and then classifying it to match the features of the known writers. We will be proposing a writer identification system for multilingual handwritten Indic text. We introduce a new multilingual handwritten Indic dataset named IIEST-Indic-HW in this paper. This contains handwritten samples from 170 writers written in Bengali and Hindi. Writers from all age groups have contributed to this dataset. The figure gives us an overview of the proposed methodology. I'll be talking more about the steps in the upcoming slides. First, the handwritten text is binarized using the method of OTSU, which separates the pixels into foreground and background. Then we extract patches from the handwritten text in two steps. We first extract patches using fractal dimensions. So in order to extract the patch using fractal dimensions, we first divide each handwritten page into non-overlapping patches of size 64 x 64. Then we apply the box counting method on each patch to calculate the fractal dimension. Now, since a large number of patches are extracted, we select the patch by calculating a threshold value, which is the average of the fractal dimensions of all the patches. The patches are then extracted by calculating the key points using oriented fast and rotated brief as shown in the figure. A 64 x 64 patch is extracted around each key point as shown in the figure. Then, just like in the previous step, we select the patches on the basis of the height of the strokes. Now, these two types of patches are given as input to a vision transformer. For each patch, a class score vector is generated, which is averaged across all the patches. This gives us the writer of the handwritten page. We propose a split for the IIEST-Indic-HW dataset. The split for the CVL database is already available, and we propose a cyclical split for the IGDA 2011 dataset. Moving on to the results section, the proposed method has been tested on the IIEST-Indic-HW dataset. The results are shown in the table. We have evaluated the proposed method on the CVL database as well, and we can see that the method achieves state-of-the-art results in case of top 1 to top 3 accuracies, and a competing result in case of top 5 accuracy. Finally, we have evaluated the method on the IGDA 2011 dataset, and the results show that the cyclical split proves to be effective in distributing the data across train, test, and validation sets. In conclusion, we propose a new multilingual handwritten Indic dataset named IIEST-Indic-HW. We also propose a method for writer identification which extracts patches in two steps and provides them as an input to a vision transformer. In addition to this, we propose a split for the IIEST-Indic-HW dataset and a cyclical split for the IGDA 2011 dataset, and evaluate our method on these datasets along with the CVL database. These are the references. Thank you for watching.